Capacitor. Capacitor is an electronic device or component that is used to store electrical charges or voltages. It is composed of two metal plates with an inserted insulator called dielectric, to separate the two metal plates of the capacitor. The amount of capacitance of the capacitor depends on the size of the plates, distance between the plate and type of dielectric. The ability of the capacitor to store electrical charges is called capacitance. Farad is the basic unit to measure capacitance of the capacitor. A 1 Farad capacitor is connected to a 1 volt supply, will store 6 quintillion 280 quadrillion electrons to be exact. But most capacitors have much smaller values. Small capacitors are specified in picofarad, PF, and larger capacitors are specified in microfarads, microfarad. So, we usually rate capacitors in microfarad, μF, and picofarad, PF. 1 μF is equal to 0.00001 F. And 1 PF is equal to 0.000000001 F. A Dutch professor at the University of Leiden named Peter van Maschenbroek invented a similar capacitor, which was named the Leiden jar, which credited as the first recorded capacitor. Capacitors are produced in a wide variety of forms: air, mica, ceramics, paper, oil, and vacuums are used as dielectrics, depending on the purpose for which the device is intended. Characteristics of a capacitor. 1. It can store electric charge even though the voltage source is already disconnected. 2. It can discharge electrical voltages. Voltage rating of capacitor. Voltage rating of capacitors specifies how large or how much voltage a particular capacitor can hold or store without destroying its dielectric material between the plates. Function of capacitors in the circuit. There are major functions of capacitor in the circuit that are based on their applications, such as coupling, decoupling, bypass, feedback, and filter. Capacitor. 1. Capacitor are used in electronic circuits as low pass, high pass, and band filters. A filter is a circuit that allows current and voltage of a specified frequency and waveform to pass through. 2. Capacitor also plays a significant role in high-speed switching logic circuits. Such circuits' voltage level, which should be steady, can change with current fluctuation, thereby introducing noise or error signals. 3. Decoupling capacitors are built into circuits to stabilize the current, minimizing noise signals. Types and symbols of capacitor. A non-polarized capacitor is a type of capacitor that can be connected any way in a circuit. In other words, there is no positive or negative. Common types of nonpolar capacitors are ceramic, mica, and some electrolytic. A capacitor stores electric charge. A capacitor is used with resistor in a timing circuit. It can also be used as a filter, to block DC signals but pass AC signals. 1. Ceramic capacitors. Ceramic capacitors are constructed with materials such as titanium acid barium for dielectric. Internally, these capacitors are not constructed as a coil, so they are well suited for use in high-frequency applications. Typically, it is used to bypass high-frequency signals to ground. They are shaped like a disc, available in very small capacitance values and very small sizes. It comes in very small size and value, very cheap, reliable. It is also subject to drifting depending on ambient temperature. 2. Silver mica. Silver mica used as a dielectric are used in resonance circuits, frequency filters, and military RF applications. Highly stable, and good temperature coefficient. Excellent for endurance because of their frequency characteristic, no large values. High voltage types available, can be expensive but worth the extra dimes. Bipolarized capacitor. Polarized capacitor is a type that must be connected the correct way round. It has positive and negative terminal lead. A capacitor is used with a resistor in a timing circuit. It can also be used as a filter, to block DC signals but pass AC signal. 1. Electrolytic capacitor. An electrolytic capacitor made of electrolyte, basically conductive salt in solvent. Aluminum electrodes are used by using a thin oxidation membrane. Most common type is polarized capacitor. Applications: ripple filters, timing circuits. It is cheap, readily available, good for storage of charge. However, it is not very accurate. Marginal electrical properties: leakage, drifting, not suitable for use in high frequency circuits, available in very small or very large values in μF. It will explode if the rated working voltage is exceeded or polarity is reversed, so be careful. 2. Tantalum. Tantalum is made of tantalum pentoxide. They are electrolytic capacitors but used with a material called tantalum for the electrodes. Superior to electrolytic capacitors. Excellent temperature and frequency characteristics. Like electrolytic, tantalum is polarized plus and indicators. It is mostly used in analog signal systems because of the lack of current spike noise. The small size fits anywhere, it is reliable and the most common values readily available. Alt-Aug, it is expensive and can easily damaged by spikes. Large values exist but may be hard to obtain. See variable capacitor. Variable capacitor is a capacitor whose capacitance can be varied. These are usually made up of one or more moving plates and one or more non-moving plates separated by the dielectric. By moving the plates, we can vary the capacitance. A variable capacitor is used in a radio tuner. 1. Tuning are core capacitors. They use the surrounding air as a dielectric. Mostly used in radio and radar equipment. This type usually has more air capacitors combined, gained, and so when the adjustment axle is turned, the capacitance of all of them changes simultaneously. 2. Trimmer capacitor. This type of variable capacitor, a trimmer, is operated with a small screwdriver or similar tool. It is designed to be set when the circuit is made and then left without further adjustment. The ceramic type has the value printed on them. Colors are yellow, 5pf, blue, 7pf, white, 10pf, green, 30pf, and brown, 60pf. Capacitor reading. Conversion of units. Testing capacitors. Remember, when testing capacitors with an ohm meter at its highest ohm range, it is set to Rx 1K or higher. When testing capacitors in the circuit with an ohm meter, be sure to switch off your power supply and be sure to disconnect first one terminal lead of the capacitor from the circuit before testing. Steps. 1. Discharge the energy stored to capacitor by shorting the two-terminal lead momentarily. 2. Set the multitester to ohm meter range. 3. Connect the positive probe to the capacitor negative terminal lead and negative probe to the positive terminal lead. Good capacitor. 1. The tester pointer will deflect and then move back to its original position. Defective capacitor. 1. The tester pointer won't deflect at all. The capacitor is open. 2. The tester pointer will rest on the 0 ohm scale. The capacitor is shorted. 3. The tester pointer deflects toward the right position but does not return to its initial position or remains stationary. The capacitor is leaky. Note, the picture below shows the pointer deflection, position to determine the condition of the capacitor.